So dispersion of variance sample mean. So we have shown that the mean of the sample mean is population mean. So the question is, how is the dispersion of sample mean? And suppose you do the sample mean, suppose you kind of reducing the variance, right? Because mean is already concentrating on things around the mean. So mean of sample mean should have less variability. And indeed, yes, turn out to be the formula is rather simple. So the mean, the variance of sample mean, or the variance of the x bar, okay, will be the population variance divided by sample size, which means that if you do a very, very large sample, the variance sample mean will become zero, right? So because you collect everything a lot of time, then a lot of n, and then we repeat, keep doing this, then actually you don't have variability. And the standard deviation of the sample mean, we have a special name we call the standard error of sample mean, will be just square root of what we have seen here. So we just the standard deviation of the population divided by root of n. Okay, so that is the thing. So let's see an example. So consider population again with three numbers, 1, 2, and 3. The sample mean is 2. The population variance is 2/3 because 1 minus 2 square is 1 plus 0 plus 3 minus 2 square divided by 3. So it's 2/3, okay? And then the sample size is 2, consider. And then 9 possible samples, right? Because a sample without replacement can be 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, can be 3, 1, 3, 2, and 3, 3. And simple random sample means 9 of them are equally likely. So we have shown the mean of this is 2. Actually, you can see you add them all up, divided by 9 is 2. So you want to see the variance of this sample mean. So basically, we have 1 and 3 is different by 1, so it's 2 times 1 square. And 1.5 and 2.5 are different from 2 by half, so it's half square times 4. And 2 minus 2 is 0, so we don't need to do it. So that's 4 plus 1, okay, over 9 is, this is 1, this is 3 over 9 is 1/3. You can rewrite as 2/3 over half. Why? Because 2 over 3 is the population variance, over 2 is the sample size if it's 2. So that's why we have validate, okay, this formula, okay, is the variance of sample mean is indeed the population variance divided by n. So that is the idea. So let's prove it. The variance of sample mean, so we just directly do the calculation, the variance, okay, and variance sample mean will be rewrite sum of the observation over n. And remember, n can be taken out, but you need to add a square, okay? And variance of the sum, okay? And remember the simple random sample, okay? This is mean they're independent. Independent means the summations are taken out because the covariance are all 0, okay? And variance of each of them is sigma square, okay? Because they are simple random sample. And the n of them, so the n here, and n square cancel out. So that's why we have sigma square over n, okay? So that is the variance of simple random sample.